This is the video for the 6.3 through 6.5 review to help you understand the answers here. So number one, it says if a quadrilateral is equiangular, then it is a rectangle. Remember that equiangular means all the angles are the same. So in a quadrilateral, we know that we have 360 degrees. And if you divide that evenly among the four angles in a quadrilateral, you get 90 apiece. So if all the angles are 90 degrees, yes, then it is a rectangle. So that is going to be true. Number two, if a quadrilateral is a parallelogram, then it is equilateral. That is false. So equilateral means that all sides are congruent. In a parallelogram, all sides do not have to be congruent. Only opposite sides have to be congruent. So, wow, that was an awful parallelogram. So we're going to try again. All right, so there we go. We know the opposite sides are congruent, but not necessarily all four. Number three, both pairs of opposite sides are congruent in a parallelogram. That is the definition of a parallelogram and what I just said. So number three is true. Number four, if the diagonals of a parallelogram are perpendicular, then it is a rhombus. If you remember, that is a quality of a rhombus when we had our rhombus lesson. So when we did this lesson over rhombuses, or rhombi, whatever, we can see that that was one of the qualities. The diagonals are perpendicular. They also bisect each other like parallelograms, since it is a parallelogram, but we know they intersect at a right angle. So yes, that would be a rhombus. So that means number four is true. Number five, the diagonals of a rectangle are perpendicular. That is actually false. So in a rectangle, they are not perpendicular. Now they are in a square because remember that a square is a combination of a rhombus and a rectangle. So it takes on all the qualities of both. So it takes the right angle perpendicular for the diagonals from the rhombus, not from the rectangle. And we can easily show that that's not true. We can see that those don't intersect at a right angle. So that is going to be false. Number six, the diagonals of a parallelogram bisect the angles in a parallelogram. And that is false. So the diagonals bisect the angles only if it's a rhombus. So it has to be more than a parallelogram. It also must be a rhombus. So hey, period one, I forgot to draw this little guy on your notes, so you might want to add it to your notes. But yes, the diagonals of a rhombus bisect both pairs of opposite angles. So for just a parallelogram, that is not true. So again, that is going to make this guy false. Number seven, if a parallelogram is equilateral, then its diagonals are congruent. So that's going to be false. So an equilateral parallelogram would fall under the category of either a rhombus or a square. But in a rhombus, the diagonals are not necessarily congruent. So we can look back at the note sheet again and see that we have these diagonals here and they still bisect each other. So we could have, labeled these like this. They still bisect each other. However, they're not necessarily congruent, against each other. They're not congruent this way, but they do intersect at a right angle. It's the square that happens down here, that the diagonals bisect each other and are congruent. So that's going to make number seven false. So we'll come back here and make it false. Okay, number eight. Both pairs of opposite angles are congruent in a parallelogram. That's obviously true. That is a quality of a parallelogram, and you can find that on the 6-3 note sheet. And you can also prove that by using parallel lines in a transversal and proving both pairs of opposite interior angles congruent for both sets, and you can prove that. Number nine, the diagonals of a parallelogram bisect each other. That is true. Again, we can prove it, and pretty easily, and we know that that's a quality of a parallelogram. Number 10, the diagonals bisect the angles of a rectangle, and that is going to be false. So the diagonals in a rhombus bisect the angles. So in a square, they also bisect the angles because it's a combination of a rectangle and a rhombus. But in a rectangle, the diagonals do not necessarily bisect the angle. So that one is going to be false. All right, moving on. Which of the following is not a property of all rhombi? So the diagonals are perpendicular. So that is true in a rhombus. Diagonals are perpendicular, so that's not it. The diagonals are congruent. That is not true in every single one. Now it could be true because remember, a square is a rhombus. So if you have a square, it's a rhombus and it has diagonals congruent. Okay, diagonals are congruent and they also bisect each other. So you would have that situation. So a square is a rhombus, so that's going to be part B. It is in some, but it's not of all rhombus. And we can go through and know that diagonals bisect the angles. That's true of all rhombi. And the opposite angles are congruent. It's still true of all rhombi. So the answer is B. Number 12, which of the following is not a property of all rectangles? So the diagonals are perpendicular. So that's actually going to be our answer there is part A because, or letter A, because again, this is true for a square, and a square is a rectangle. So for some rectangles, that is true, but it's more specifically a square that happens in. So part A is not true for all rectangles. Part B is true. In a rectangle, the diagonals are congruent. And then opposite sides are congruent. Opposite angles are congruent, I'm sorry, is true because it's a parallelogram. And the diagonals bisect each other again. It's a parallelogram and that happens for all of them. So the answer to number 12 is A. For number 13, which of the following is a property of all parallelograms? The diagonals are perpendicular. That is not true. That will happen for a rhombus. Letter B, the diagonals are congruent is not always true. Okay, that happens for rectangles and squares. For part C, or letter C, the diagonals bisect the angles. Again, that's only going to be true in a rhombus and a square. And so the last one we're left with is the opposite angles are congruent, and that's true. We know that that's true for all parallelograms. So D is your answer there. Okay, moving on. This is the part where we figure out the most precise name we can name these based on the given information. So number 1, we can see it's a parallelogram at least because it's got opposite sides parallel. Cool. And then we know one pair of consecutive sides are congruent. So since we already know it's a parallelogram from the opposite sides parallel, I know opposite sides are congruent too. So if this one, has a 1 tick mark, then this one's congruent to that. And again, 1 tick mark, so this gives 1 tick mark. So all 4 sides are congruent. We know it's a parallelogram, okay? But we don't know anything else about anything. We don't know if this is a right angle. It looks like it, but we aren't told that. And we don't know anything about that. But we can actually say that this is a rhombus. So now we know it's a rhombus, so actually this is a right angle. And we know it's a rhombus because you have all 4 sides congruent and it's a parallelogram. That is the definition of a rhombus. We can't say it's a square because we don't know, although it looks like it, we don't know if the diagonals are congruent and bisect each other. Well, we know they bisect each other, but we don't know that they are congruent. All right, the second one, we know, again, it's a parallelogram, so that's pretty easy. Now, I do know that the diagonals are congruent and bisect each other. So that tells me it's at least a rectangle. Now, can I confirm that it's a square? Okay, I know all 4 right angles are 90 because I said it's a rectangle. Because these qualities happen in a rectangle. The fact that they bisect and are congruent, the diagonals. We need another additional piece of information to make it a square. We need to know that that's a right angle. The diagonals perpendicular. So the most specific we can name this is rectangle. All right, number 16. We have, we don't have opposite sides parallel, both sides opposite parallel, so we can't say parallelogram yet. Oh, but I know that one pair of sides is parallel, and that same pair is congruent. That is one of our qualities in our sheets. So back on our worksheet for 6.3, we had all the ways we could say that something is a parallelogram. Well, it's right here. It says if one pair of opposite sides is parallel and congruent, that's enough information to say that it's a parallelogram. So we know that number 16 is a parallelogram. We do not have enough information to conclude anything else. All right, next one, 17. We've got that diagonals bisect each other. They're not congruent though. They just bisect each other, but they bisect each other at a right angle. So that is enough information to conclude that it is a rhombus. Okay, the only time you can have those qualities happen, the diagonals bisect each other in the right angle, is if you have a parallelogram. So that will happen in a rhombus. And we can't confirm that it's a square because we don't know that these angles are right angles or not. And also because the diagonals are not congruent, it can't be a square. And the last one here, number 18, I've got opposite sides, opposite angles congruent, and one pair of opposite sides congruent. So we really don't need to know that one pair of opposite sides is congruent. It's enough that both pairs of opposite angles are congruent. That's enough to know that it's a parallelogram, and this extra bit of information doesn't tell us anything else. It doesn't tell us that it's, a rhombus or a rectangle or anything like that. So the most specific we can get here is parallelogram. Moving on, we got some problems we're going to solve down here. Okay, we're supposed to find x. We can obviously see that it's a parallelogram, so I know opposite angles are congruent. So I know that 2x plus 37 is equal to 4x plus 25. And I'm going to subtract 2x from both sides. At the same time, subtract 25 from both sides, and I get 12 is equal to 2x. Divide by 2. So x is equal to 6. Number 20, again, parallelogram because of the markings. So I know that same side interior here, those are going to add up to 180. So I'm going to say 2x plus 37 plus 4x plus 25 is equal to 180. So that's 6x plus, 62 is equal to 180. Subtract 62 from both sides. See how I'm showing my work? And then I get, I'm going to put it over here. 6x is equal to 118. Divide each side by 6, and that's not going to divide evenly, so it's x is equal to 19 and 2/3. So that's x for number 20. For number 21, I again have a parallelogram. So I know that opposite interior angles are congruent, okay, because this would be my transversal. I'll just draw it on there. That would be your transversal. You know these two are congruent, so you know that opposite interior angles, alternate interior angles are congruent. So 9x is equal to 45, which means x is obviously equal to 5, and that's all you needed to know. This was just an extra bit of information. You can't use that because you don't know what this adds up to here. It's not 180 because you don't, if you're looking, that would be these here, including this out here. All right. Next one. Given rectangle ABCD, you've got those links there, so I'm going to label them. Oh, no, I'm not. Okay, so the diagonals here are what you're given. Since it's a rectangle, you know the diagonals are congruent, so I know their measures are equal. So I can set those two equal to each other. Subtract 3x from both sides. I'm going to add 15 at the same time. So we get 3x is equal to 33. Divide by 3. X is equal to 11, but that's not my question, so you got to pay attention. The question is, what is AC? So really, you can plug it back into either one because AC and BD are congruent. So which one is AC though? The first one. So 6 times 11 minus 15, 66 minus 15, and that's going to be 51. So AC is equal to 51, and you can confirm 11 times 3 is 33, and 33 plus 18 is also 51. All right, now moving on to the stuff you probably really care about down here. So is it enough information? Okay, so is it enough information to determine that the figure is a parallelogram, yes or no? All right, so I'm going to mark up this figure a few times. So for the first one, GP is congruent to HK, and GH is congruent to PK. So opposite sides congruent. Yes, that is enough information to say that it's a parallelogram. Okay, there's no other way you can put those pieces together to form a quadrilateral without it being a parallelogram. All right, let's see if it'll let me erase here. Oh, yay. Okay. All right, the next one. Measure of angle 7 is equal to measure of angle 3. So 7 and 3. And the measure of angle 8 is equal to the measure of angle 4. Congruent to, equal to the measure of angle 4. So you're actually using a converse theorem here of alternate interior angles. So let's look at them separately. So I'm actually going to erase the 8 and 4 one. All right, so if we're just looking at those, remember we got to figure out what our transversal is. So that's a line that's going to form them both. So that'll be the transversal is GK. Now you have to draw in just the other two lines that help form the angle. So to form angle 7, I need PG, and to form angle 3, I need HK. So I extend those out. All right, so because alternate interior angles are congruent, therefore the lines are parallel. So from that statement, from measure of angle 7 is congruent to measure of angle 3, equal to the measure of angle 3, I know that GP is parallel to HK. I'm going to do the same thing with the other ones. So it won't let me erase. Come on. Oh, what? Okay, that took way too long. All right, so now the next set here, measure of angle 8 and 4. So if you know those are equal, then draw the transversal that makes them. And then the two lines that help form those angles are also GP and HK. So again, alternate interior angles congruent. The converse of that theorem says that those lines must be parallel. So again, those two angles only tell me that GP is parallel to HK. So although I'm giving two pieces of information, it just retells me that those two lines are parallel. I don't know anything about these other two, so therefore, no, it's not enough information to conclude that it is a parallelogram. All right, number 25, if you know that the measure of angle 5 and 1 are congruent, or equal. Okay, so here and here. Again, I'm going to look at the transversal. So the transversal here would be there. And then what other lines help form the angles would be GH and PK. So since alternate interior angles are congruent, I know that that fact tells me that GH is parallel to PK. All right, and now the 7 and 3, I can see from the last one, it's not going to change. If I know that the measure of angle 7 and 3 are congruent, equal, then that means it tells me this other one. It tells me GP and HK are parallel. So I know opposite sides are parallel. Therefore, yes, this is enough information to know that it's a parallelogram. For number 26, I know that GH is parallel to PK and GH is congruent to PK. So I know one pair of opposite sides are congruent and parallel. Yes, that's enough information to tell me that it is a parallelogram. That was one of our theorems in the beginning, a way to determine if it is a parallelogram or not. All right, next one, if GP is parallel to HK and HG is congruent to PK, This one is not enough information because I know one pair is parallel and another pair is congruent, but it has to be the same pair, like in number 26. One pair has to be both congruent and parallel. So this one is not enough information. So 27 is no. For number 28, it says n is the midpoint of both diagonals. So if they share a midpoint, that means that the diagonals bisect each other. It does not mean they're congruent to each other, but that they bisect each other. So yes, because the diagonals bisect each other, that is enough information to tell us that it is a parallelogram. Again, that's another one from 6.3, a theorem that tells us that's enough information to determine if something is a parallelogram. All right, next one. We know that the measure of angle 8 is equal to the measure of angle 1. And I know that the measure of angle 5 is equal to the measure of angle 4. So that tells me that the diagonal bisects both of the angles. However, that's not enough information because these actually have to be congruent to each other, and I don't know anything about these two. So that is not going to be enough information. So no. And the last one. If you know that angle 8 and angle 4 are congruent, and 5 and 1 are congruent. So we can clearly see that that means that one pair of opposite angles is congruent since you're adding the same two angles together. So let's look at the transversal here. So I know if I draw this one here, and let's look at 4 and 8. So for 4 and 8, if I draw the other two lines that form it, I can see that alternate interior angles are congruent. Therefore, I know that GP is parallel to HK. All right, now if I take that away, two lines now that form angles 1 and 5, so that would be the top and the bottom. Again, we have alternate interior angles congruent, therefore these two lines, GH and PK, are parallel. And now I know that opposite sides are parallel. Therefore, yes, this is a parallelogram. So that is enough information to tell me that that's a parallelogram. Okay, that's it. So if you have any other questions, just let me know. And your concept check is tomorrow. Thanks for watching.